In this video, we're going to look at another example of separable differential equations. The question here asks us to find an equation of the curve that has slope of the tangent line f prime of x is equal to 1 plus root of f of x and passes through 0, 9. 0, 9 is a point on the curve. Those are xy coordinates. The first step is to rewrite f of x as y, and let's rewrite f prime of x as dy dx. This way we can set up a differential equation and solve it. So we get f prime of x, which is dy dx, is equal to 1 plus root y. This is a differential equation. We're going to apply separation of variables to solve this. So let's separate the variables. Dy divided by 1 plus root y is equal to dx divided by 1. So this is just basic algebra. So as an example, if you have a over b equals c over d, now everyone knows cross multiplication, say AD equals BC. But there's other forms of what I call cross multiplication that you may not be aware of, and that can be very useful. For example, A divided by C is equal to B divided by D. Or equivalently, C divided by A is equal to D divided by B. So that's what we're doing in this case to separate the variables. And be careful on this step, because if this step is wrong, if there's algebraic error, then it will propagate through and the whole solution right down the pipe will be wrong, of course. So now we can integrate both sides, and after we have separated the variables, so we have dy integral of 1 over 1 plus root y dy is equal to integral 1 dx. Now, how do we integrate the left-hand side? That's going to be a little bit hard. We're going to apply U substitution. So we're going to let U be equal to the denominator. Let me use green color for that. U is equal to 1 plus root y. Differentiate both sides. We get du is equal to 1 over 2 root y dy. Now let's solve for dy. So dy is equal to 2 root y du, but root y is equal to u minus 1. So let's rewrite dy in terms of u. So we get dy is equal to 2 times root y, which is u minus 1, times du. So all of this is a u substitution that we're going to use to solve this integral on the left. All right, so we have integral dy, we have simplified it to 2 times u minus 1 times du, divided by the denominator 1 plus root y, that's the substitution u. On the right-hand side, integral 1 is just going to be x plus c. Now 2 is a constant, passes through the integral, so we get 2 integral, and let's divide the numerator over denominator. U over u is 1 minus 1 over u, in brackets, du is equal to x plus c. Now integrating the left-hand side, what is the antiderivative of 1? That's just going to be u, minus, what is the antiderivative of 1 over u? That's log of u. This is equal to x plus c. All right, so now what we have is 2 times u minus log of absolute value of u is equal to x plus c. Now let's substitute u is equal to 1 plus root y, so we get the answer in terms of y. So we have 2 times 1 plus root y minus log of absolute value of 1 plus root y is equal to x plus c. And let's close the bracket here as well. All right, so now let's divide by 2, and we're going to get 1 plus root y minus log of, we don't need the absolute value because root y is a positive quantity, so 1 plus root y is positive, no need for absolute value. So log of 1 plus root y, this is equal to x over 2 plus c over 2, and we're just going to call c over 2 another constant, say c1. So we get x over 2 plus c1, where c1 is equal to c over 2. All right, so what we have is 1 plus root y minus log of 1 plus root y is equal to x over 2 plus c1. Now let's apply the initial condition, which is y of 0 equals 9, because the curve passes through the point 0 and 9. So y of 0 equals 9. That means that when x equals 0, the y value is equal to 9. So let's substitute that in. We get 1 plus root of 9 minus log of 1 plus root of 9 is equal to, and the x value is 0, 0 divided by 2 is 0, plus c1. Root of 9 is 3, 3 plus 1, that's going to give us 4, minus log of 4 is equal to c1. We have solved for c1. So the solution is 1 plus root y minus log of 1 plus root y is equal to x over 2 plus c1, which is 4, minus log 4. This is the implicit solution for the differential equation. So what we have is 1 plus root y minus log of 1 plus root y is equal to x over 2 plus 4 minus log 4. This is the implicit solution for the differential equation that was given in the question, dy dx is equal to 1 plus root y. And we also know that that curve goes through the point 0, 9, which of course means y of 0 equals 9, because this is the x value, x is 0, and this is the y value, y equals 9. All right, thanks.